Hello, this is Sam Melvin. I'm here to explain about International Data Encryption Algorithm, 19MS0006. International Data Encryption Algorithm is also known as IDA algorithm. IDA is an encryption algorithm. It is a symmetric block cipher that takes 64 bit as an input, 28 bit as key, and performs 8 identical rounds for encryption, which is 6 different subkeys are used, and 4 keys are used for output transformation. And these are the steps involved, major steps like involved in IDA algorithm, like step 1, step 2, step 3, and these results in the cipher text, which is the encrypted text. Actually, this encryption is used in data transformation, uh, data sharing, file sharing, passwords, authentication, etc. It will be encrypted in such a way that other third party will not be able to read, write, etc. We will see something about IDA, like solving a problem. IDA, it uses a fixed length plain text of 16-bit and encrypts them in 4 chunks of 4-bit each. To produce 16-bit cipher text, it takes a plain text of 16-bit and it encrypts it into 4 chunks, like 4 chunks in the sense 4 times 4 bits, that is 16 bits. To produce 16-bit cipher text, the length of the keys used in is 32-bit. The key is 32-bit. The key is also divided into 8 blocks of 4 bits each. The 32-bit is divided by 4, 8 blocks of 4 bits. This algorithm involves a series of 4 identical complete rounds and 1 half round. 4 identical round means like the cipher text will be the resultant after the plain text goes under these 4 identical complete rounds, and one half round has 14 steps. These rounds have 14 steps each round, like round 1, round 2, round 3, and round 4 has separate 14 steps, and these 14 steps come around between around between revolve around between additional modulo, multiplication modulo, and bitwise XOR. These 14 steps are revolving around in these 3 main operations. Before we enter into problem, we should know how this IDA algorithm works. This algorithm involves a series of 4 identical complete rounds and 1 half round. Each complete round involves a series of 14 steps that includes operations like bitwise XOR, addition modulo, multiplication modulo, plus 1. After 4 complete rounds, the final half round consists of only the first 4 out of the 14 steps previously used in the full rounds. To perform these rounds, each binary notation must be converted to its equivalent decimal notation. Perform the operation, and the result obtained should be converted back to arbitrary binary representation for the final result of particular step. In this, they say like the final output is taken from the 4.5th step. Key schedule. See 6 key subkeys of 4 bits out of 8 subkeys used in each complete round, while 4 are used in half round. That is, we have up to K6, and K4 will be we are using K6 out of K8 and K4 out of K8 in 4.5 round. So 4.5 round required 28 subkeys. The K given key K directly gives the first 8 subkeys. By rotating the main key left by 6 bits, each group of 8 further groups subkeys are created. We will be shifting 6 bits, so to create each pair of key for each round. So further, the 8 subkeys are created, implying less than 1 rotation per round for a key. This is the image of IDA algorithm, where a model or addition, model application, multiplication, and the bitwise XOR are done. So we'll take an example. We have a key of 32-bit and a plain text of a 16-bit and a cipher text. We'll find the cipher text. we are in this example, we are going to take this plain text and key to find the ciphertext, and we will cross check if we are answers correct or not. In round one, we are taking plain text as 4 chunks of 4 bits, and ciphertext as 6 chunks, like 6 chunks as 4 bits. So we'll be taking up to 1111, that is 15. Step-wise involved, the steps involved in this calculations are x1 into k1, x2 plus k2, x3 plus k3, x4 into k4, where step 1 power step 3, and will be of like 14 steps, like step 2 power step 4, step 5 into k5, step 6 plus step 7, step 8 into k6, step 7 plus step 9, step 1 power step 9, step 3 power step 9, step 2 power step 10, step 4 power step 10. These are followed for 4 rounds. Each round has these 14 steps which revolve around these major operations, which I shown before, like addition, modulo, multiplication, modulo, bitwise, XOR. After the last complete round, the half round is done, right? So the half round will use only x1 into k1, x2 plus k1, k2, x3 plus k3, x4 into k4. So we'll consider our plain text as x1, x2, x3, and x4, and k1, k2, k3 as etc. as key. So as for the first round, we are going to multiply plain text x1 into k1, that is 1001, that is 9, 1101, 13. Mod, if we do mod 17 for that, we'll get 15. I will do for that is a value is 9 into 13. We can calculate using a calculator. What is 9 into 13? 9 into 13 will be 117. That is, a value is 117. B value will be 70. We get answer of 15. Yeah, answer is 15. When you might have wondered why there is a 17 and why there is a 16. This steps revolve around the operations like multiplication, modulo multiplication, additional modulus, and bitwise or multiplicative modulus will follow mod, like we have to do mod 17, and for addition we have to do mod 16. It is a procedure actually. So 12 plus 12 is 24, 24 mod 16 is 8. We'll check once. 24, 16. Yeah, 8 we got. Same for 1010, that is 10 plus 0110, 6 mod of these two, that is 16 mod 16 is 0. These steps came from these 14 steps. The step 1, which is x1 into x1, x2 plus k2, and so on. Then 1100, that is 12 into 11115 of mod 17 gives 10. 15 into 12, what is 15 into 12? 15 into 12 gives 180 of modulus 10. Modulus 17 is equal to 10. Yeah, and if we do the power, 15 power 0 is 58 power 10 is 2. 15 into 3, that is 45 mod 17 is 11. 2 plus 11, that is 13 mod 16 is 13. 13, 13 to 15, that gives some value. And if we proceed according to the steps, we will be getting this answer. and these things will give us the output. And these 14 steps are it is procedure that we should follow these kind, and these 14 steps will be applicable only in up to 4 rounds, and 4 point will have only the top 4 steps to find the final ciphertext. And we are going to do it, do these steps for that 14, do these steps in first round, which is nearly 14 steps, and the last 4 steps gives us the output. The last 4 steps, the value for last 4 steps are 0 1 1 1 1 0 0 0 1 0 1 1 1 0 0 1. And as per procedure, we will be interchanging the 13th and 14th step. Like we got 12th and 13th step, sorry. 12th step is 0 1 0 0 0 and 13th is 1 0 1 1. So we'll be interchanging in output of round 1. And the K value, you might have wondered where the K value comes from. The K value comes from the above table. This is the table which the K value comes from. For round 1, this is the K value. For round 2, we'll be taking this K value. Round 3, round 4, and round 4, 5, 5. We'll check for round 2. We'll be doing same as round 1. We'll be getting, when we follow the same steps, like these 14 steps, with these 3 operations, we'll get answer 0 1 1 0 0 1 1 0 1 1 1 0 1 1 0 0. We'll be this is the output after interchanging 12th and the 13th step. Round 3 also will give an output of 0 1 0 0 1 1 1 0 1 0 1 1 0 0 1 0. Round 4 will be giving an output of 0 0 1 1 0 1 1 1 1 0 1 1 1 0 1 0 0 0. After completing these 4 complete rounds, we'll be stepping to 4.5, like that is half round. So in this, we will be doing only these part, x1 into k1, x2 into x2 plus k2. So here in round 14.4.5, we'll be taking, we will be having k values up to 4, whereas in other rounds we'll be having k value up to 6. And we need not interchange the 13th, 12th and 13th value. So we'll be writing as it is. So after the round 4.5 gives the final ciphertext. The final ciphertext is 1011 1011 10 0 1 0 0 1 0 1 1. And we'll be checking with the cross checking with our initial answer 1 0 1. Yeah, we got the same 1 0 1 1 1 0 1 0 0 1 0 1 1. So this is the ID algorithm. I will again explain the gist of this algorithm. ID algorithm will take 16-bit of plain text, 16-bit of ciphertext, and the key will be 32 bits. Plain text will be 16 bits, and it will encrypt into 4 chunks of 4 bits, same 16 bits only, to produce ciphertext of 16 bits. The length of key is used as it is divided to 8 blocks of 4 bits. Each this algorithm has 4 identical rounds, and all first round 1, round 2, round 3, and round 4 are the same. It will follow the same steps. Only last round, that is 1.5 round, will be having only the top 4 steps. And in these identical 4 rounds, we will be interchanging 12th and 13th step to get our final answer. And in 4.5 round, we need not do anything like that. So because we have only K4, whereas in other 4 rounds we'll be having up to K6. The main operations are addition modulo, multiplication modulo, bitwise XOR. The steps are first 10 steps. It will be using addition modulo operators like addition modulo and multiplication modulo. And the last 4 steps gives the we'll be using XOR, bitwise XOR. And moreover, the last 4 steps, the bitwise XOR gives us the output for that particular round, and that particular round is taken as X value for the next round, and that if we get this round 2, answer for round 2 is taken as X values for round 3. the output for X3 is taken as X value for round 4, and round 4 is done for round 4.5, and the final output of round 4.5 is the final ciphertext. These rounds are carried out for each steps. Like it will be round 2 is for round 3, round 3 is for round 4, like that. And the K value will be getting from the above table. For round 1 to 4, we'll be having K6. For round 4.5, we'll be having K4. And we'll be getting the ciphertext. We now see some IDA in real life. Once brute force technique became stronger, the US government and encryption committee looked to replace for the NIST approved DES that was widely used. IDA was proposed as a replacement algorithm for DES, which shows that it is more powerful than DES, and it is used by US government to, when the brute force attacks was very like overdoing, when it was famous and people are doing brute force attacks. But it failed to do so today era, but it failed because of the strong thing. So it was replaced by it failed, which in the sense DES failed to stop brute force attack, but the replacement IDA became an absolute, and which done a great job in avoiding and preventing from brute force attacks. And I guess this is end of the topic, and thank you very much. Thank you.